All right, so today we're going to take some time to look at determining whether something is a solution given an inequality. So we might be looking at graphs, we might be looking at linear inequalities, which is something we'll look at a little more later in the chapter, but we're going to kind of take a look at the graph today to kind of determine what solutions are and aren't, and how to determine where the solutions actually are, okay? So again, this is not going to be too bad as long as we understand what the graphing is. So go ahead and start with graphing this do now today. All right, so if you remember, we always read from the variable. So x is greater than -7. So here's 0, here's -7. It's going to be an open circle to the right. So if I'm looking at solutions, I'm looking at everything above -7, okay? Everything above -7. So let's think about this graph, okay? And let's look at some numbers. So let's start with where the solutions actually are. So if I take a look at this inequality and I write the inequality, I have x. I see that the arrow is going to the left, so I know it has to be either less than or equal to. I also see that this is a closed circle. So I know this has to be less than or equal to -3, okay? So the first question is -3 a solution? This is going to be yes. And the reason it's going to be yes is twofold. One, it's a closed circle, okay? Because of the equal to. It's a closed circle because of the equal to. So that makes it a solution. So let's be the same thing over here on this 20. I have x is less than or equal to 20. This one would also be a solution, okay? Because of the equal to. It is a closed circle. That determines whether or not the 20 is included. Now, is -7 a solution? Yes. -7 is a solution because my solutions are over here. So that means -7 is actually smaller than -3. So that works. What about 3? 3 is here. 3 is a no. That is not in the shaded region. Okay? It is not in the shaded region. So it is not a solution. Okay? It is not a solution. All right. Let's go ahead and solve this guy. Well, actually, let's not solve this guy. Let's see if we can do it without solving. So instead of solving and graphing, can we determine if something is a solution by just looking at numbers? You certainly can. Okay, we're going to substitute. Because I don't want to solve, I don't want to graph, that's too much work. I just want to do a substitution. So let's go ahead and put in the 2. And I'm going to put the 2 in where the x is. Okay, so here's the 2. Less than or equal to 4. Well, 3 times 2 is 6. 6 minus 2 is 4. So I have 4 is greater than or equal to 4. Is that true or is that false? Well, 4 is equal to 4. So that is true. So that means this is a solution. Okay, 2 is a solution. What about -3? So 3 times -3 minus 2 less than or equal to 4. So -9 minus 2. So I have -11 is greater than or equal to +4. Is that true or false? -11 is not greater than or equal to 4. So that is false. So that is no. That is not a solution. All right, what about 3? 3 times 3 minus 2. So 9 minus 2 is going to give me 7. Is 7 greater than or equal to 4? Yes, so that is a solution. Okay, that is a solution because that is true. So we can use substitution pretty easily to be able to determine if something is a solution. It's pretty quick. We don't have to solve the equation and graph. All we have to do is use substitution and decide whether that is true or false. All right, now let's take a look at a linear inequality. Okay, now this is a little different because just like we have a number line and we have a closed circle and to the right, and we know that the solutions are going to be underneath the shaded region, Okay? Notice how this has a shaded region. The same type of shaded region as this. Okay, so down here are the solutions. Anything that is in the shaded region is a solution. So these are not solutions. Okay, so where there's no color, those are not solutions. Now, the other thing that I want you to notice is look at this line. That is an open line. Okay, so the open line is the same as an open circle. So that would mean we're either looking at greater than or equal to or less than or equal to. It doesn't have the line underneath to make it equal. So if I'm looking at points, this point right here is not a solution. Okay, neither is this one. It is not a solution. But this point is a solution because it's in the shaded region. Now, if I am on the line, okay, I'm on the line, unfortunately, this one is not a solution, okay, because it is an open line. It is an open line. So shaded region are solutions. So anything down here, that's a solution. This is a solution. This is a solution. But if it's an open line, a dashed line like this, it's not a solution, okay? That is the same as being in the non-shaded region. All right, let's go ahead and see if you can substitute these and decide whether these are solutions. Okay, notice how this time we have an x and a y. So are you going to substitute once or are you going to substitute twice? All right, let's see if you figured it out. Okay, so since I have two variables, I'm substituting twice. So in the x spot goes the 2, and in the y spot goes the 3. So I have 4 minus 9 greater than 7. So negative 5 greater than 7. Is negative 5 greater than 7? True or false? Well, that is definitely false. Okay, that is definitely false. So 2, 3 would not be a solution. All right, let's try another one. 2 and negative 1. 3 and negative 4 greater than 7. So hopefully many of you are thinking, well, that's going to be bigger because of all the negatives. You're right. I have negative 2 plus 12 greater than 7. So 10 greater than 7. That is true. So this one is a solution. Okay, this one is not a solution, but this one is a solution. So I can actually substitute and solve and determine if they're solutions, even if I have two variables, an x and a y on an ordered pair, which is going to look like a graph on this guy. All right, so today you're going to be working on determining if things are solutions. So lots of substitution and lots of reading graphs today. We'll catch you as we move into compound inequalities.